Good to see you, curious minds. In April 2026, a team at Xiaomi released something that made a lot of people in the agent world quietly put down their coffee. MiMo version 2.5-Pro, a fully open source, 1.02 trillion parameter mixture of experts, model with 42 billion active parameters, native 1 million context, and a demonstrated ability to autonomously build a complete university-level compiler in Rust from scratch across 672 tool calls in just 4.3 hours, and get a perfect score. Not a toy task, not a cherry-picked demo. A real hidden test suite compiler that normally takes computer science students several weeks. Today, we are going deep on MiMo version 2.5 and its flagship Pro sibling. The architecture that makes these long, coherent runs possible. The almost embarrassing token efficiency numbers. The open source reality. The pricing that has certain other labs looking over their shoulders. And whether this really is one of the strongest practical agentic models you can run right now, closed or open, ears forward. This one earns the length. MiMo version 2.5 and MiMo version 2.5-Pro come from Xiaomi's MiMo team. Both are fully open sourced under a permissive MIT license that explicitly allows commercial use, continued training, and fine-tuning. The Pro variant is the one that turns heads. 1.02 trillion total parameters, 42 billion active in a sparse MoE, hybrid attention architecture with interleaved sliding window, and global attention, native multi-token prediction for dramatically faster output, and up to 1 million token context. It was trained on 27 trillion tokens and then put through a sophisticated 3-stage post-training process. SFT, domain-specialized RL teachers, and multi-teacher on policy distillation. Specifically optimized for long-horizon agentic work in complex software engineering. This is not a generalist model that happens to be big. It was built for exactly the kind of sustained multi-thousand-step autonomous trajectories that separate impressive demos from actually useful agents. Let us talk about what this thing has actually done in public. One of the flagship examples, taking a Peking University Compiler Principles course project, a complete sys-y compiler in Rust, with Lexer, Parser, AST, IR generation, RISC-V backend, and performance optimization. And completing it autonomously, the reference implementation usually takes a strong CS student several weeks. MiMo version 2.5-Pro, properly harnessed. Finished in 4.3 hours across 672 tool calls, and scored 233 out of 233 on the hidden test suite. It did not thrash, it scaffolded the full pipeline first, nailed the IR 110 out of 110, then the backend 103 out of 103, then the optimizations. When a refactoring pass at turn 512 introduced a regression, it diagnosed the failure and recovered. Another run, building a complete desktop video editor with multi-track timeline, clip trimming, crossfades, audio mixing, and export pipeline. 8,192 lines of code, 1,868 tool calls, 11.5 hours of autonomous work. These are not right-of-function tasks. These are multi-day expert-level engineering projects executed end-to-end. Here's the part that actually matters. For people running agents at scale, on Claw Eval, a demanding agentic benchmark, MiMo version 2.5-Pro hits around 64% pass cubed, while using roughly 70K tokens per trajectory. That is 40 to 60% fewer tokens than Claude Opus 4.6, Gemini 3.1 Pro, or GPT. 5. 4 equivalents at comparable capability. The model is not just matching frontier performance on certain agentic and coding workloads. It is doing so while being dramatically cheaper to run, especially once you factor in the excellent caching behavior the team has engineered for long agent loops. For anyone who has watched their monthly agent bill climb during heavy development sprints, those numbers are genuinely exciting. The technical decisions are worth understanding because they directly enable the long-horizon behavior. Hybrid attention with a 6-to-1 ratio of sliding window to global attention, and a 128 token window slashes KV cache requirements by nearly 7 times while a learnable attention sync bias preserves. Performance at extreme context lengths. The native 3-layer multi-token prediction module doesn't just speed up inference. It was designed with RL rollouts in mind, tripling output throughput during training as well. The post-training uses multi-teacher on-policy distillation to let a single student model absorb the strengths of specialist teachers without the usual distillation tax. The result is a model that stays coherent and self-correcting across hundreds or thousands of steps. Both models and the base versions are available on Hugging Face under the Xiaomi MiMo organization, with full weights, tokenizer, and model cards. Deployment guides exist for SG-Lang and VLLM, with specific recipes for the MoE plus speculative decoding setup. The API via the Xiaomi MiMo platform is OpenAI compatible and has seen aggressive permanent price reductions, in some cases dramatically undercutting other frontier-class offerings. With flat context pricing and no penalty for the full 1 million context. There are also specialized siblings, strong open ASR, and controllable TTS models that pair naturally with agentic voice use cases. A sophisticated fox always checks under the rock. Self-hosting the full 1.02T-Pro model is obviously hardware-intensive. Serious quantization is required for consumer GPUs. The inference ecosystem is still maturing. There have been the usual teething issues in VLLM, SG-Lang, and Llama.cpp around specific quants and the model's attention head dimensions. Some community members have noted prompt and format sensitivity in edge cases. While the Agentic results are excellent, it does not yet dominate every single closed frontier model on every single benchmark. It is exceptionally strong, but it is not magic. MiMo-v2.5-Pro is one of the most interesting open agentic releases of 2026 so far. Not because it claims to be the single best model on every metric, but because it delivers frontier-class long-horizon performance with remarkable token efficiency, ships fully open under a permissive license, and backs it up with concrete, reproducible engineering wins that take most humans days or weeks. The links to the models, the platform, and the detailed technical report are in the description. If you are building serious agent workflows and you like the idea of that kind of capability without sending everything through someone else's closed system, you should probably go have a look. Until next time, curious minds, keep those ears perked for the models that actually let agents finish what they start. I'll see you in the next one. Catch you next time!